Good morning, everyone. Welcome to this session. Just want to put in the chat box there, if you can all see me and see my screen, okay, because it's disconcerting. Oh, thumbs up from Bernd. Awesome. Thanks very much. So let's get going. So my name is Robin Moffatt. I'm a developer advocate at Confluent, one of the companies that contribute to the open source Apache Kafka project. I'm just going to move my Zoom windows around so I can actually see what I'm doing and talking to here. Move that out of the way and that down there. So we're going to talk about building Telegram bots. I've got a fun little example of an open API that I found and hooked up to various different things that I want to show you this morning. I'm going to do questions towards the end, but if you have questions as you go through, put them in the chat box and I'll answer them at appropriate points, but we'll definitely get some at the end. If you do the Twitters, then do feel free to follow me. I'm at @rmoff. You'll find it plastered across most of the slides, and I'll share it again at the end. If I don't get a chance to get to your questions, or if you have a burning question that comes up afterwards, then feel free to send me a message on Twitter. My DMs are open if you want to send it that way. I'm always happy to answer any questions that I can do. So we're going to build a Telegram bot. But what's it going to do for us? Well, that scene that you can see there is a nice little sunset over the countryside where I live. And this is a nice view down into the little town of Ilkley where I live. It's out in the countryside. It's like nicely in the middle of the countryside. It's beautiful walks and running. And I went for a run this morning to try and wake myself up before this talk because virtual conferences are always kind of hard to get that energy going. But anyway, I live in Ilkley, small little place, middle of the countryside. And sometimes you need to go places, so you hop in your car and you go to like maybe a place like Bradford, which is a nearby city. And if you've driven there, well, there's great public transport. If you've driven there, you're going to find somewhere to park your car. So you go into this big city, and you think, I need a car park. Or as we say in West Yorkshire, a car park, kind of the pronunciation differs, but we need a car park. So you're driving in your car and you think, well, I've got my kind of like, need to find somewhere to leave my car. I wonder where my nearest car park is that's got some parking spaces. Or there's a particular car park that I've got in mind. You think, well, I wonder how many spaces there are at that particular one. Or we go to our first couple of car parks and they're all full. So we think, well, wouldn't it be useful if my phone could tell me when a particular space becomes available? Or being a bit of a data geek, you kind of think, well, I wonder how the occupancy varies over time. Like, do particular car parks get busy at different times in the day? So all of these questions are bubbling away in my mind as I'm kind of on my way to Bradford to try and park my car. And I think, well, wouldn't it be wonderful if there was an API that someone had provided that told me about car park occupancy? And it turns out there is. So the Northern Data Hub is a good source of data for data in the north of England. And one of the things is the car parks themselves actually report data about their occupancy. So this car park here, this many empty spaces. And it's fairly rudimentary data, but it's rather useful because we can build fun things like this. We can hook it up to a tool like Telegram. So if you're familiar with Telegram, then great. If you're not, it's like WhatsApp, it's like Messenger. It's a tool that you can do chats with, but it's also got a really nice bot API as well. So we can write some cool little tools. So that's what we're going to do. We're going to take a stream of data from this API. I'm going to show you the API and show how we're going to get that data. And we're going to use that data and build it into a bot that's going to answer our questions like, where's my nearest car park? Or can you tell me when there's a car park comes available with some spaces free for me? So that's what we're going to do. I'm going to show you what it actually looks like. And we're going to walk through building it out. And then I'll show you some more slides that actually kind of put into context what we've built. I'll make sure I share the slides afterwards. I believe the session is being recorded and will also be shared, but I'll make sure all of this stuff will go online. What is also online is at the bottom of the screen there. Let me point to that. That address there will take you, in fact, that QR code, I believe as well, will take you to the actual code that I'm going to show you. It's all on GitHub, and you can go and try it out for yourself. The API I'm using is an open one, so you can just connect to it and pull out the data. So it's all built around Docker, so you can just go and spin it up and try it for yourself. So let's see what it actually looks like. So this is the fun thing about doing live demos. You've got to cross your fingers. I'm dependent on a live third-party API. Hopefully it won't go down. I did this talk once and it did, which is embarrassing, but cross your fingers. So here's our bot. It's our Kafka Alerts bot. You click on Start. And it says, okay, welcome to the bot. Here are the things that you can do. And if we get a chance, I'm actually going to show you the code that sits behind this. But to start off with, I'm going to say, okay, there's a particular car park I'm interested in. It's called Broadway. So I'm going to say, okay, how many spaces are available in the Broadway car park? So hit enter there, and it says, okay, car park Broadway is 16% full. It's got 1,000 spaces available. Okay, so that's useful to know. So I'm definitely going to have somewhere to park if I head towards that one. So I'm just going to have a look, because see if I can mute people, because there's someone being noisy on the line there. I'm not sure who it is. It's definitely not me. I'll tell you what, if you could all do me a favor, make sure you have muted yourselves, and then it'll save me doing that, and I can do the talk. So anyway, we've got Broadway car park. There's 1,000 spaces available. That's good news. How about, though, if I say, well, actually, where's my nearest car park? So I'm going to say, well, this is where I am. I'm going to send my location. So Telegram and other stuff lets you share your location. It's useful if you're meeting up with your friends, and you could each share your location and say where you're going to. But it's also useful with a bot. You can say to a bot, here's where I am, and it can do things relative to your actual location. So we say, okay, where's my location? And my location is somewhere up here, and we drop it on the map, and we send that location. And it says, okay, I'm going to find your nearest car park. And it says the nearest car park is one called Westgate. It's 14 kilometers away, like I said. Ilkley's kind of like a bit of a distance from Bradford, and it's got 112 spaces free. So it's not got as many as Broadway, but it's definitely still got plenty. But let's say, hypothetically, because using a live API, it's harder to mock up different scenarios, but let's just say all of these particular car parks are full, and we say, well, I really need to know when there is a space available. So we're going to say set an alert. So let's say we'll set an alert. There's an entire convoy, there's an entire platoon of us arriving, and we need 500 spaces. So now what it's going to do is, instead of actually going and looking up against that data that it's got from the API, it's going to say, next time we get some data from the API, it's going to tell us if it matches this condition. So this is where the event-driven bit comes in. And the talk title was all about Apache Kafka. I'm going to talk lots more about events and capturing events into state, and also taking events and using them to drive certain actions. And the reason I keep on talking is that this API refreshes periodically, and hopefully at some point it's going to push an event. If it doesn't, I'm going to cheat. I'm going to trigger it from here. And I'm going to get it to do this. And hopefully any moment now, it's going to push through, it's going to get a feed from the API, it's going to say, do any of those match this condition of 500 spaces being available? And if it doesn't, then we put it down to the live demo gods, not particularly favoring us this morning. Okay, it's not going to work, never mind. What we're going to do now, though, is we're going to look at how we actually built this kind of thing out. So let me bring this up onto the screen. I'm going to cancel that there, because obviously it's not playing ball with us this morning. And we're going to put this up here, and we're going to look at some code. So let's cancel that and cancel that. And what we're going to do is, I'm actually going to walk through that demo code that I showed you. So if you want to go and look up what I'm doing, if you want to try it for yourselves, it's all on GitHub. I'll share the link again later. But let's have a look at this actual API that we're using. So it's just a HTTP GET against this particular endpoint here, and it returns a dump of CSV. So it's a little bit yucky to start with, because it's just comma-separated stuff. It's got a header line here, but you can see we've got the date, and we've got the time, and we've got the name, and we've got the number of places that are free, and then the longitude, latitude, and a few other bits and pieces. So what we're going to do is, we're going to capture this stream of events into a Kafka topic. Now, you may well argue, oh, well, when someone does a lookup against this, why don't we just poll the API? But A, that doesn't serve the purposes here of wanting to build something around Kafka, because that's what I like to do. But also actually in practice, would you really want to be polling a third-party API if you have like thousands of users running something like this? It's going to be much easier to actually capture that data into one place from which you can serve those requests. So we're going to capture that data into one place, which in this case is Kafka. So to do that, we need to get this data in. Now, there's different ways of getting data into Kafka. In practice, you would probably write yourself an application, use the producer API of Kafka to get the data and push it into a topic, or you'd use Kafka Connect, which is a really good tool for doing integration with third-party systems into Kafka. Here, I'm going to go a little bit of a hacky route, but it's kind of effective and quick. We're going to say, I'm going to take this data, and to start off with, we're going to strip off that header, because that's not actually a row of data, that's just header information. We don't need that. So taking the curl output and piping it through that, we've now just got a bunch of messages. So this message here, that message there. These are just individual rows of data. And then we load it into Kafka. And we're going to do this using a tool called KafkaCat. Or nowadays it's been renamed to KCat for ASF reasons, but we pipe from tail and we pipe it into KafkaCat, and it acts as a producer. So this is a hacky command line way of actually doing what you would probably do with a producer API and a real live application. But this is now sending data into Kafka. The -t acts as a T, it's going to echo it to the screen. What I can do here is I can actually say, go and consume that data from the topic. So let's go and look at what data is in that topic. Use the -c to consume it. So we can see within this topic here, end of topic car parks, offset 24, we've got these individual messages. So let's set that running. So I'm going to use a while loop that's on my history that we can do that with. So we're just going to say while 1 = 1, do this forever, load the data into the topic and do it every 3 minutes, because that's approximately how often the API itself updates. So that's going to sit there. It's going to sit there streaming the data from the API into a Kafka topic. Now from that Kafka topic, we now want to serve up information to our end users. So we're going to write an application which is going to use that data in the Kafka topic to do a bunch of different things. It's going to do event-driven notifications. So this one's relatively straightforward, because we're going to say, when we get some new data, look at the data, apply a predicate. If it's more than the alert threshold they said, so if there's more than any spaces, or if there's more than 500 spaces, then send that message out to the user. The things we're going to do, though, are based on state. That user is going to say, I want to know for this particular car park, how many spaces are currently available. So our application is going to need to look up against the stream of data we've got coming in, what the state is. So this is where a tool called ksqlDB comes in, and I want to show you that now. Because what ksqlDB lets you do is, it lets you take a stream of data in a Kafka topic. It lets you write queries against it using SQL against the stream of data. It also lets you take that stream of data and build materialized views on top of it that you can then query directly with an application. So let me show you what that looks like. So what we've got here is our ksqlDB prompt. There's a web interface as well, if you'd rather. And to start off with, they say show topics. What topics have we got on the system? Well, there's just one topic called car parks. If I say print car parks, it's going to say, as that data arrives in the topic, I'll echo it to the screen. Well, we could sit here and we could wait for 3 minutes for that poll to refresh, or we could just say, show me the data that's already in the topic. So show me the data from beginning. It says, here is the data from the beginning. So you've got things like the row time, you've got the key. So Kafka messages are key value bytes. We've not set the key when we sent the data to it. We just dumped in a value of the actual message, which is this here. So you've just got a string dumped into the value of the message and no particular key set. And these are all in partition 0 because it's a single partition topic. So we've got a bunch of delimited data in our topic, but we're going to start working with that data in terms of actual fields, because we want to look at the state for a given car park. So car park itself is a field. How do I identify that field within this long string of delimited data? Well, we apply a schema to it. And if we eyeball it, we can see there's a schema. The CSV had a schema. It had that header row that said it's a name and then a comma and then this and a comma. And CSV is like, it's not the nicest way of encoding data, but it just about works most of the time, as long as you don't have commas. So what we're going to do is we're going to say, well, let's take that schema and let's make it official. Let's actually say within ksqlDB, create a stream. So a stream is a Kafka topic, but with a schema. It's an immutable, unbounded series of events, which is what a Kafka topic is, but it has a schema on top of it. So here is the schema. There's a date, and it's a varchar, time, name, capacity. These are different fields that the CSV header told us was there. And we say the data's in a Kafka topic that already exists, called car parks, and the data's delimited. If the data was JSON, if it was Avro or Protobuf or JSON schema or whatever, we could do the same thing. So data in a Kafka topic is just bytes. We just need to know how to deserialize it and how to understand it. But in this case, it's delimited. And we could use a different delimiter if we want to, but we just use the default of a comma. So now we've got a topic called car parks. And on top of it, we've got a stream called car parks source. So car park source is just an arbitrary name that we've given it. It's based on top of this particular topic here. The value format is delimited. The key format's Kafka. We can ignore that because we don't have a key that we've set. If I say describe car park source, it says car park source, it's a stream, and here is its schema. We can do this, I can probably say describe extended, and it tells us a little bit more about it. How do we define it? And again, the details of the schema there. But because we've got a schema, it means we can actually project fields from that stream. So instead of saying select everything from the stream, let me just show you that. So if I say, first off, we're going to say set the offset back to the earliest. So data in a Kafka topic is persisted, it's stored for as long as you want it to. So by loading the data from the API into the topic, we're capturing that history, because the API just gives us what's the current state of the car park. Whereas we're going to say, what's the history of it over time, because we could show you a little bit of analytics later on as well. So we've got the data in the topic, it's building up over time. We can rewind and go back to the beginning of the topic and say, well, let's look at the data from there, which is what we're telling ksqlDB to do here. And then we can say select star from car park source. And we can type it in correctly. And then it says, okay, here's all the data from the topic. So we've got our date, we've got our time, we've got the name, we've got the capacity, the number of empty spaces, and the longitude and latitude of the car park. So there's all the data in the topic. Select star from topic. But we can also say, actually, just pick out some particular fields within that topic. So just select the date and time, the name, and how many empty places there are, and just show me the first 5. So it says, okay, starting at 8:20 this morning, UTC, car park here, Westgate, 112 empty places, Crown Court, 100 empty places. So now we're starting to pick through that topic, which is just bytes, which we said, actually, those bytes is a delimited string. That delimited string has got a schema to it. Now we can pick out particular fields. We can do things like this. We could say, select it from car park where empty places is greater than 100. And now it says, okay, here are the ones where empty places is greater than 100. So we're applying predicates to the data that we're pulling out of that Kafka topic. But what we're going to do now is we're going to say, take that raw stream of data, that existing data that we've pulled in and modeled, we've kind of like declared a schema on top of it. Now let's transform it a little bit. Let's kind of get it into the kind of shape that we want that data to be able to work with it. Because we want to do things like this. We want to be able to say, well, that date is a string and that time is a string. And as we generally know, that's a fairly crappy way to handle date time. Let's actually store it as an actual timestamp. So in this case, we're going to store it as a timestamp object, so big int, number of milliseconds since the Unix epoch, because then you can work with it properly. We're also going to take the latitude and longitude, which at the moment are just double values separately, and we're going to create those into a struct, because then that in itself can be used to do geodistance functions as well later on. So this looks like this. And we're going to say select from here, and we're going to paste it up here. And it looks like this. So we're going to say string to timestamp, date plus time, and here's the format of it. We're going to pull in everything already that's in the particular stream. We do some calculations. We're going to say we can work out the percentage full. So is it 100% full? Is it 10% full? By working out how many places are being occupied at the moment, divide that by the capacity to give us the percentage. We create a struct of the latitude and the longitude, and we're going to call that location. We're also going to add in a static field, which is going to give us the source of the data. Because if we get time later on, I'm going to show you how I can add in additional sources of data into the same target stream. Because this one here is coming from the API called v2 council car park current. We can add in data that's historic. We can add in data from other cities, because the logical data model is pretty much going to be consistent. What's the car park name? How many empty places are there? So you're going to find APIs for different cities, which are going to probably supply the data in a different way. We can wrangle that and get it into the same target stream because it's logically the same data model. So if I run that and just say limit 5, just showing the first 5, it's going to say, here's how it now looks. So there's our big int, number of milliseconds since the epoch. here's our object here that holds the latitude, longitude. And instead of just writing it out to the screen, we're going to say, we'd like to persist that into a new Kafka topic. So now we're saying create a stream called car park events. I'm going to serialize the data using protobuf. Now I'm going to use protobuf. You could use Avro, you could use JSON schema. But the important thing here is the schema for the data is now going to get stored in a schema registry. So instead of dumping it as like a delimited string, which was like fairly crappy, and we had to declare the schema again, and it's error prone and tedious, instead we store the data in a new Kafka topic. We're going to serialize it using protobuf, and that schema gets stored separately, which means when we want to use that data, we can read the schema from the schema registry, and we know what all the different fields and data types are, which is a good thing. So we say create stream, and that stream is now populated by the results of that select statement. So we've run a select, but it's not dumping it out to the screen, it's dumping it out and populating this stream here. So if I say describe car park events, we can see it's got a schema. We can see the schema's got that object there that we've created. It's got a timestamp as a big int. If I just say describe that extended, you can see how many messages have we processed in total, how many per second are we processing, when was the last one received. So that's 8:21 UTC, it's 9:21 BST at the moment, 10:21 Central European time. So that's like as of now, it's processing that data. So just a quick little recap. We've got the data coming in from the API, we're streaming it into a topic. That topic we're reading from as each event arrives, processing it, building out like the location object and doing those transformations into a new target object. So now what we've got, if I say show topics, topics, is a new topic called car park events. And if I say print car park events, you can see as the data is arriving, it's actually transforming that data, it's building out those new objects, but it's still just a Kafka topic. So we've got ksqlDB that's doing that processing, doing that stream processing for us. So we can use this particular one to satisfy that requirement from our application, which is as a new event arrives, does it have more than a certain number of places available? So let me show you what that looks like. We can say select star from car park events where empty places is greater than 500, and it changes. And now it's going to say, actually, what we'll do is we'll set the latest offset. So by saying latest offset, we're saying as that data arrives, read from the end of the topic. So as the data arrives, we're going to evaluate that predicate, but it's going to ignore everything that's there already, because we don't want to know, tell me an alert about something that was available back then. We want to deal in real-time data. So there it goes, it's loaded up, there's our APIs just polled. So we've received an update, it's evaluated that event, it said these two ones here have got more than 500 spaces, so it's matched that condition. And in this case, the select is echoed out to the screen. But what we can do also is we can run it as a REST call. So let me show you that. So what we're going to do is we're going to say, run this. I'm just going to use curl to show you this, but you could use Postman if you prefer that. And obviously you can use the REST API directly from within your applications, which is what the Telegram bot is doing. So we're going to say, use the curl call. Here's our REST endpoint, the query stream endpoint for ksqlDB. We're going to say, just like I showed you a minute ago, we're going to for the latest offset, so from the end of the topic, and we're going to run this. Select the name, select the timestamp, and the empty places. In this case, we're just going to say if there's more than any empty places. So let's change that. Let's say 500 empty places. So now my REST call is running. It's sat there. So if this is your application that's made the HTTP request, it's going to wait for that to return. And when we get an update from the API, it's going to push that data through. So let me just do that. So I'm going to split my screen again. I'm going to do a call against Bradford. And it's going to do this. So at the bottom here, I'm just doing a manual pull against the API to push the data into that source Kafka topic. So it's pushing it into the source topic, which is then going to get transformed into that car park events one that we saw there. So as I run this here, we should see that REST API call here update any moment as it pushes it through. Unless the demo gods, again, are going to frown upon me. which potentially they are, or there's not more than 500 spaces available to park at the moment. Oh well. Why is that not working? Let's just try it from here. So select it where that's more than 500. So we're doing that there. I push the data into there. Okay, so my REST call for some reason, I'll tell you why. Because my REST call here is saying where the name is Westgate. So Westgate itself doesn't have more than 500. So this is why I should have followed my script instead of just ad-libbing. So let's close that there and try this one again, because I can't actually take the crushing disappointment of all of our live demos failing. So let's run our curl call here, which is going to say where we have, so get rid of that predicate. So where empty places is more than 500. So querying from the latest, and down here, cross all your fingers, or don't if you want to see this crash and burn. So we do a pull against the API, that pulls the data in, and there we go. Phew, whew. We got our data coming back. So our REST API is doing an event-driven push. As the events load into that Kafka topic, they then get evaluated for that predicate and pushed out to the REST API here, which here is just a curl dumping it out to the command line, but in practice would be your application receiving an event. Okay, phew, we've ticked that one off the list. We've got a way of doing event-driven notifications from our application, doing a REST call saying, tell me when this predicate is met. And since it's a Kafka topic, your application could also just run a consumer and consume from that feed directly if it wanted to, and apply its own predicates. It depends where you want to push that particular processing logic. But the next bit that I want to show you is how we can actually determine state from that stream of events. And this is where it gets a little bit more kind of less obvious, because if you're familiar with Kafka, with streaming, with events, the idea of an event-driven notification is one of the first kind of concepts that you encounter. Events happen all the time. We put them in this immutable log, and they can be used to drive actions. So as something happens, we evaluate it. Does it match the condition? If it does, create an action from it. But these streams of events, we can also build into state. We can say, let's actually look at this in practice. So we'll close that, and we'll close that. And we'll bring back up our ksqlDB prompt. So we can say for our streams of events. So if we go and have a look at our car park table, our car park stream. So let's set the offset back to the earliest. And let's say select the select name and empty places and time from car park events where our name is, we call this Westgate, and it changes. We can see that as time goes by, you get different events for a particular car park. So the car park is going to be our key. That's the thing that we're interested in. We're saying, like, based on the key, based on the car park, how many empty places are there over time? Those are our events coming out. This particular time, this many empty places, this many empty places. And the event is, I guess, a car coming into the car park or a car leaving. That's the event. It changes the state. But we want to say, as of now, how many empty places are there? So as a human, we look at that list and we say, well, what's the most recent time? And so there are 106. And that's kind of like, you eyeball it and you say, well, that's how many empty places there are currently, because that's the most recent event that we have. Well, ksqlDB can, in effect, I'm putting it very, very simplistically, can do that for you. It can say, build a materialized view over this stream of events that says, create an aggregation and say for a particular key, what's the aggregate? So we've got an aggregation of latest by offset. We've got aggregations of minimum and maximum and average and all the rest of it, but you've also got latest. So you can say, what's the latest value for these different fields for a given key? And once you can do that, you can then actually do a lookup against it. So let me show you what that looks like. So here we're going to build a materialized view. So we're going to say, create a new object. And before we created a stream, we said, we've got an existing topic, declare a schema on it, and then use that stream to build another stream with various derivations around the timestamps and the objects and stuff like that. But now we're going to create another object that's a table, because tables are state. Tables are values for a key. So we're going to say create a table called car park as the name, which is our key, and we do a group by that key. And then we say the latest by offset, the capacity, the number of empty places. We can create an average of the number of empty places. And we set that running. And that has now created, show tables, it's created a table. We're serializing it as protobuf. And the reason we're serializing it is that it's actually writing it to a Kafka topic. So this is working like getting a little bit more than we're going to get a chance to cover today. But Kafka topics are a stream of events. Tables are also, in effect, you can capture a table's behavior as a stream of events. Every change to a table is an event. And you can replay those events to build the table state. It's called the stream table duality. And it's a really, really powerful concept. It means that so long as you've got the events from a system, you can build the state. And if you can capture the changes to a state, you can get the events from which you could build that state. What we're going to do now is we're going to say, well, from this table that we've just built, how many spaces are there currently free? So select the timestamp, the empty places, don't need average empty places. From car park, where name equals Westgate. So just to point out, we're at the ksqlDB prompt here. We're not going against the relational database. This is going against ksqlDB, which is just ksqlDB plus Apache Kafka. It says, well, there are this many empty places currently. So you can do these state lookups against the materialized view. And we could also do something. So this was added in ksqlDB quite recently. If you're familiar with it, you may be aware that you didn't used to be able to do this. You can actually do a full table scan against that table and do non-key lookups. How many car parks are there currently where it's got more than a certain number of empty places? So let me say 500. So these two car parks at the moment have got more than 500 empty places. So that's doing a full table scan. So if you think back to like a relational database, that's probably going to perform fairly badly if you've got lots and lots of data that's kind of like not suitably arranged and so on, but you can do that. So now we can say, well, let's use that REST API to actually look at that data. So again, this is where our excuse me, where our application itself would come in. Instead of running it in a ksqlDB interactive command line session, we could, from our application, do a post request, a query stream to say, give me the number of empty places currently for this given car park. And we run that and it says, okay, that's the number of empty places currently for that car park. Currently, there's 106 available at this particular time here. That's the latest time we got from the API. So we've got a stream of events. We've got a materialized view on that stream of events within ksqlDB. And now our applications can do stateful lookups against those values. So the piece that we've not got in any of this is like another data store where we're storing stuff to do lookups. We can do lookups directly against a stream of events using ksqlDB to build that materialized view. So I want to show you a couple of slides just to kind of go over the concepts. And then if we've got time, I'll show you a bit more of the code behind it. If not, the code itself is on GitHub, so you can see it there also. Just have a quick look. There's been no chat. So if you've got any questions, I presume you're saving them up for the end. But if you have any questions, feel free to put them into the chat. It saves that awkward silence at the end. When we get to the end, I'll say any questions, and there's silence. So think of any questions, put them in the chat if you want to. I'll answer them after this. So this is what we're starting to build out. We're starting to pull out data from an API, streaming it into Kafka, and then using an application I've written in Go. I realize it's the Java conference, hope you'll forgive me. And we're using that application to query the state directly from Kafka and to get handle the events being pushed from Kafka to push out to our user. The other piece that I'll show you briefly after this is actually being able to build some analytics on top of the same stream of data. So some of the key concepts here, right? Obviously building Telegram bots against stream of car park information. It's a fun little science fair project. It's like a great little thing to do for a talk like this. But in practice, within our organizations, when we're thinking about how do we build systems, I've got a new system to build, a new service to build, how I'm actually going to use this and do this. So the key things I want you to take away are this idea of being able to do event-driven alerts, being able to say, as something happens somewhere, I can react to that. So instead of my application polling somewhere and saying, like, I need to go and look at this thing and see if it's happened yet, I can actually handle events as they occur, and then I can use those to drive an action in my service. Also, the concept of being able to do materialized views on a stream of data, being able to do key value lookups from an application. So within an event stream, we can build that into a materialized view. So the event stream is going to be populated by streams of events from somewhere, from a producer API, from Kafka Connect, from something hooking into a database to feed it into Kafka, but something happens. We can build that into a materialized view. We can then handle questions from an application, can say something like, how many spaces are currently free? That translates into, in this case, a SQL query against that materialized view, which then returns an answer straight away. It's a stateful lookup, which is then returned out to the application. One of the things we also did was we applied a schema to the data, because the data coming from the API was like this lump of CSV, which is like I say, it's not a particularly nice way to interchange data. It's been used for decades. It probably still will be, but I wish it wouldn't, because it's like ambiguous, it's error prone, it's tedious. So we can actually apply schemas to a stream of data, which then makes it much, much easier for other applications downstream to work with. So we can say, well, take this particular inbound source of data, apply the schema, and then serialize it back onto a new topic, which everyone else can read from and benefit from. The bit that I do want to show you now, though, is kind of like the final piece of the puzzle. And again, one of the reasons for using Kafka in this piece, it's not just about, I've got a source of data that I want to build an application against, and I build that and I'm done. It's about thinking of this concept of events in our business. So an event happens, numerous systems and teams will probably want to use those events. So instead of this mindset of like, I've got this point-to-point integration to do, I will build it using this tool, and then I'm done. It's like, I'm fine. Everyone else can I do it your way? I'm done. I've done my point-to-point integration. You think about, we have an event. A customer bought something, a car parked in this parking space. Multiple systems and teams will probably want to know about that and use that data. So if we're capturing it into something like Kafka, you can use it to drive your applications. You can build your state and all the rest of it from there. But you can use that same stream of data captured and stored once, multiple times independently, because we can also take that same stream of data and push it out into somewhere else, like Elasticsearch, for example, to build a dashboard on top of. So let me show you very briefly how that works, and then I'll wrap up. So within ksqlDB, let's bring ksqlDB back up here. And we're going to do a call out to something called Kafka Connect, which I would love to talk about at length, but I've run out of time to do so. So I'll just show you in action conceptually what it does. We say we've got data in our car park event stream. We'd like to push it into Elasticsearch. So we use the Elasticsearch connector. And we set that going. And we say show connectors. And it says it's running. Okay, which then means we can go over into Elasticsearch. And we can open that up. And within Elasticsearch, if I zoom in there, we can say we've got an index that's been created called car park events. So Elasticsearch is just like a document store. If you're not familiar with it, you can just chuck data at it, it stores it. And once it's stored it, you can visualize it. So you can say, here's my data in the system. And you can see over the last 15 minutes, let's zoom that out a little bit. So here's the data coming in. You can see every 3 minutes or so, we get some information from the API coming through. We can visualize it. We can say, let's build ourselves a nice little visualization and click through here and say we're interested in the number of empty places. We'd like to split it down here by a particular car park. So you can see there's my different car parks and how the empty spaces vary over time. So within a kind of like a half-hour time segment, it's not particularly so interesting. Whereas if we looked at it like this and capture it over a period of time, so I've had this running for a while, you can say, well, how does it vary over the course of a day? And you can also plot it to this time last year. So like we had COVID and like lockdown and stuff like that. So you can see the number of empty places was much higher because everyone was locked down and staying at home. Whereas now people are generally getting back into work, so car parks are busier, so there's fewer empty places. And because we've got the latitude and longitude within the data, you can also plot it onto the map. You can say, where are those particular car parks? We can say, well, the number of empty places defines the strength of the heat spot, which is shown. And you can zoom into that. You can show the number of empty places there. So because we've got that data within Kafka, we've captured it once from the source. So the source, in this case, we're kind of like pulling it from there, but it could be producing it. You've got it as a stream of events on a Kafka topic. It can drive our applications. It can also be used to push out to analytical systems, and it can do so independently. If one of those goes offline, the other one keeps on running because they're decoupled, completely separate. You've just got that Kafka topic that they're reading from. And they can also rewind and reread from if they want to. So let me briefly skip ahead through a whole bunch of slides because I totally ran out of time. And you can download them offline if you want to. But this is the kind of thing that we've built. We've got our data coming through from our Kafka topic. We're doing our event-driven alerting, like I showed you with the Telegram bot. We're doing key value lookups. That's the really kind of new thing that you can do using data in Kafka, but with ksqlDB on top. If you would rather use Kafka streams, you can also do that. So ksqlDB gives you the SQL interface. Kafka streams is part of Apache Kafka. It gives you a Java library to do similar stream processing. In fact, more so because ksqlDB is built on Kafka streams. So everything ksqlDB can do, Kafka streams can. Kafka streams can actually do even more. So stateful lookups and global tables and all that kind of stuff. And we've also done our streaming ETL as well, all coming from that same single point of integration, pulling the data into that Kafka topic. So to learn more, we get, you can go and try out the demo yourself. There's the link for it. As I say, it's on GitHub. Excuse me. To learn more about Kafka and Kafka streams and all sorts of stuff like that, there's a bunch of free training courses on Confluent Developer. So make sure you go and check those out. Confluent Cloud is where you can go and get managed Kafka service and ksqlDB service as well. So you can go and try that out. There's a bunch of credits and stuff like that for signing up also. So with that, thank you very much for your time. I hope that's been interesting. Hopefully it's kind of like prompted a few different ideas around how you can build systems around Kafka, the idea of using Kafka streams and stream processing. Check out the talks that I've got on YouTube, so YouTube/armoff. You can always go and subscribe there. Other talks I've got on that URL there, and follow me at armoff on Twitter. You can ask me questions there, and if I've got time, I'll answer questions now also. But thank you very much for your time. So let's have a look. Is it possible to use indexes on materialized views of data streams? That's an excellent question. So the short answer is no, and the longer answer is no, you can't. Because if you kind of think about it, I think about it in two different ways. You've got the relational database, which is built on top of an immutable, unbounded series of events, like the transaction log. And over the decades, we've added in all these different layers and stuff like that, including indexes. Whereas Apache Kafka gives you that immutable, unbounded log of events, which is the Apache Kafka topic. And we're starting to add in things on top of that. We're starting to add in things like Kafka streams and ksqlDB. And you can start to do things like foreign key joins between them. But things like indexes, you basically brew your own. You create a stream processor, which would take a series of events and rekey them, so that then you're basically creating your own index. So if you've got certain data access paths that require that, then that's the route you would take. You would basically do it yourself. Can you give me a link to a comparison between open source version of Kafka and the Confluent platform? I can. Actually, I can't think of a link to hand, but follow me on Twitter, send me a message there. In short, Apache Kafka is Apache Kafka, Kafka Connect, and Kafka Streams. And then Confluent Platform, you've got the community license pieces, including ksqlDB and schema registry and some of the connectors. And then you've got Confluent Platform, the enterprise piece with a bunch of other stuff around it. But send me a message on Twitter and I'll get you a proper answer to that. Does ksqlDB provide migrations if the schema changes? So yes, it does. So ksqlDB is release. They release a new version, I think, every month or so. They've got a really good release cadence going with that now. And they've been making a bunch of changes recently, particularly around the kind of the operational side of things. Because in the early days, it was like, oh, wow, Kafka topic with SQL, this is amazing. And then people wanted to use it, and you come to deploy it, and you have to do things like drop everything and start again if you wanted to make any changes. And that's obviously really painful. So they'll be making a bunch of really good improvements around the migration. And as a schema changes, you can add in things or whatever. But it also then prompts a bunch of questions around, if you think about a database and a schema migration, it's a static lump of data going to a static lump of data. Whereas a stream processor, if you start changing that, it gets a lot more complicated once you dig into it. Some things are easy. So if you say, we're going to add in this field and it's got a default, well, you just add in that field and it's got a default. Whereas if you've got derivations and stuff like that, so the short answer is, yes, there is support, but there are some cases where either that support is still to be done, or where actually it it doesn't logically make sense to do it. So in part, yes, you can do migrations, but you'll hit certain cases where it says, well, we can't do this yet, or it doesn't make sense to do that at all. But go and check out ksqlDB.io, and you can find the release notes and developments around that. There's also a really active community around ksqlDB on the Confluent Community Forum, on the Confluent Community Slack group as well. So that's also a great place to go and hang out. Awesome. Some nice messages there. So thank you very much. If anyone else has more questions, I think we've got 4 minutes before I get kicked off this. But again, thank you very much for your time. I hope it's been interesting. If you do have questions, I'm always open to answering them on Twitter. If you prefer email, you'll be able to find my email. I'll be on LinkedIn and stuff like that. But with that, thank you very much. I'll be sharing the slides. I'll be sending them to JCON to send out. I'll be putting them on my LinkedIn, on my Twitters, on wherever else you can find me online, which is fairly shameless and everywhere. So do enjoy the rest of the conference, everyone, and thank you very much.